What you see behind me in that tiny little window is a 1999 artificial life simulation. It's a Creatures 3 game, but it's a port from the original C++ engine to a modern macOS architecture with one special addition, a Model Context Protocol server which is directly wired into the engine of Creatures. MCP is an open standard which lets AI agents to talk directly to your applications via tool calling. In this case, I've implemented HTTP REST API into the engine's main thread and wrapped it with Node.js MCP adapter. That means that my AI agents, in this case Google's anti-gravity IDE, are able to talk directly to the application, meaning directly to the Creatures 3 engine, and monitor, observe, and control the game in real time.
Let me show you what that looks like in practice. I asked the agent to pause the game, and it does, by calling the pause_engine tool. The simulation freezes, but the API stays responsive. I can unpause it just as easily with resume_engine. This is possible because the engine processes API requests on its main thread through a thread-safe work queue, so pause and resume are first-class operations. Now here's where it gets interesting. I asked the agent to give me a full status report on every creature in the world. Behind the scenes, it makes several parallel API calls. List_creatures to enumerate them, get_creature_chemistry to pull all 256 biochemical concentrations, and get_creature_brain, plus get_brain_lobe to read the neural state of individual brain lobes. It then synthesizes all of this into a structured report. For each creature, it tells me their drive levels, hunger, tiredness, anger, interprets the biochemistry, flags that both creatures have critically low health despite high energy reserves, and reads the decision lobe to tell me what each creature was last thinking about. The Grendel's last decision before falling asleep was eat. The Norn is actively trying to get a nearby gadget, probably looking for food. None of this required me to open any inspector, parse any data, or write any queries. The AI agent has the same level of access to the simulation that an internal debugger would: drives, chemicals, organ health, neuron activity, synaptic weights, all through a clean tool interface. The architecture is straightforward. The engine exposes 15 tools, everything from executing arbitrary chaos code to inspecting individual agents to setting breakpoints on a creature's script virtual machine and single-stepping through it. The Model Context Protocol server is a thin adapter. It receives tool calls over STDIO, translates them to HTTP requests against the engine's debug server, and returns the results. There's no custom protocol. It's standard MCP, which means any compatible client can connect.
What really excites me about this project is the convergence. The game, originally from 1999, ran the first trials and simulations of emergent life, for example, genetics, neural networks, biochemistry, and all this running on a hardware from 1999. But to interact effectively with the simulation and with the game systems, it would be very impractical for human beings to do that in real time. But with MCP, we are able to connect directly into the game. We are able to connect modern large language models into the game and let the AI reason about, think about, interact with, monitor the game. So this is something that really excites me.
This is a port, not a rewrite. The original Creatures 3 engine code is running here. I've added docking station compatibility, developer tooling, and now this MCP layer. But the creatures themselves are the same neural network-driven agents they were 26 years ago. The difference is that now something else can actually understand what's going on inside their heads.